Okay, so in today's lesson, we're going to talk about completing the square, which is a method that we can use to not only solve quadratics, but also to rewrite them from standard into vertex form. You've actually done completing the square before in geometry when you rewrote circles, equations of circles, so we're really just revisiting that today. So in this example, they've given us two ways of solving the given equation. X squared minus 6x plus 9 equals 16. So notice that Hannah in this left example has done what we have already studied, and that is to solve this by factoring. Notice that in the very beginning, she sets the function equal to 0. She then picks two values that multiply to give us -7. Let me change colors, sorry here. -7, and adds to give us -6. So her numbers are -7 and +1. She then writes two factors, uses the zero product property, and then arrives to say that there are two solutions where x is 7 and x is -1. We know that this is a valid process because we've done this before, and mathematically it works. So now we need to look at this other process called completing the square. So that's what Enrique has done. We need to make sure we copy this down. I'm just going to talk you through some of the steps. So the first thing is that Enrique notices that what is given to him on the left is a perfect square trinomial. And that is because of the pattern or the relationship between the two numbers. So let me show you what a perfect square trinomial is. X minus 3 squared is going to be a perfect square. So I'm going to work this out and show you the pattern between the numbers. And what I want you to notice is that when we multiply perfect square trinomials, we get this doubling effect on the inside term, and we always are going to end with a perfect square at the end. So notice that that is happening in this problem. -6 is the double of 3, and 9 is the perfect square of 3. So we can rewrite that to be the quantity x minus 3 squared. Once we have x minus 3 squared, what Enrique goes on to do is to take the square root of both sides, and that's to say then that x minus 3 either equals 4 or -4. Remember, when we do this, we get plus or minus when we take a square root. And so then when he solves that out and adds 3 to both sides, he gets the exact same solutions, x equals 7 and x equals -1. All right, so today we're going to talk about how we do that, how we're going to recognize those, and how we can solve problems using this pattern. So looking at two quick, easy examples here, I notice in this first example that I have x squared plus 14x plus 49. And what I see is that if I take half of 14, that's going to give me 7, and 7 squared is 49. Which tells me that this is a perfect square trinomial. So I can set this up and rewrite this as 25 equals x plus 7 squared. I can now, just like we see in that first example, take the square root of both sides, which is going to leave me with x plus 7. And I'm going to write this in a different format. I'm going to say this equals plus or minus the square root of 5. Lastly, I can subtract 7 from both sides. And I just have to remember that this is going to give me two different answers. Either x equals +5 minus 7, or x equals -5 minus 7. So that's going to lead me to two solutions, x equals -2 and also -12. We can do this with this other example, so if you will pause and take a minute, see if you can rewrite this other example in a trinomial form or a perfect square form. And you should have gotten x minus 5 squared equals -16. I picked this one because I wanted to show you. This gives me x minus 5 equals, I'm still going to get plus or minus, so make sure that you make a note of that in your notes that you should get two answers. Remember, square roots and negatives are going to give me I, plus or minus 4i. So I can add 5 to both sides. And in this instance, because what I'm adding 5 to is an imaginary number, I can't actually add that. So I'm just going to write my answer as 5, with a pen, not a highlighter, 5 plus or minus 4i. And I will leave my answer in this complex form. All right, so in this example, we're going to talk about doing the same type of thing, but you might notice already that after you copy this problem down, these numbers 8 and 5 don't work together to make a perfect square trinomial. I can figure out half of 8, which is going to be 4, So that tells me if it were a perfect square trinomial, this would be x plus 4. But also, if it were a perfect square trinomial, this number would not be 5. So we need to figure out how do we remedy that situation. So what we're going to do, I'm going to erase this, we're going to kind of reset up this problem, and I'm going to move some things around. So x squared plus 8x plus blank equals negative 5. I'm going to move this 5 to the other side. And I'm also going to add another blank to the other side. And here's the reason. If I'm adding some unknown value to the left, I need to add that same value to the right so that it stays equal. Well, I know that value I need is going to be, I'm going to need to do half of this 8, so this is going to become x plus 4 squared. So it's going to be whatever 4 squared is, which in this case is 16. So if you're making a note to yourself, this is you squaring the value. Well, if you add 16 to one side, we're going to need to add 16 to the other, which is going to make this problem read x plus 4 squared equals 11. And then at this point, we could proceed forward like we did in the previous example to find solutions. Now, you might want to rewatch this last minute and a half just to make sure you understand this example before moving on to the next one, because something's going to be a little bit different in that example. All right, so this last example is for us to talk about how to change things from standard form into vertex form. So we're going to start by rewriting this equation, 2x squared minus 20x plus 7, y equals. And in this example, I noticed a few things. One, I noticed that this number isn't going to work. I also noticed that there's a number here in the front that we haven't really talked about or had to deal with yet. So let's talk about both of those things. So I'm going to rewrite this as 2x squared minus 20x plus blank plus 7. Now, notice that I did not change the sign of this because I haven't moved the 7 across the equal sign. And because I'm going to add a number on one side, and both of these things are going to happen on the same side, I'm also going to subtract that number. So notice that these are meant to be opposites because they're on the same side. It's not happening one on the left and one on the right this time. So now in this perfect square trinomial, I also notice that I have a 2 in the front. So I'm going to take the 2 out and write this as x squared minus 2, not minus 2x, minus 10x, excuse me, plus blank. All right, and we're going to work our way, we're kind of going to work our way down and then back up. So if I were to fill in this blank right now, I would need to put a 25 right here. And the reason I know that is because I know that half of 10, if I go down one more time, I should use half of 10. It's going to leave me with x minus 5 squared. So I'm going to square that number and get 25. But when I go up the next level, what I need to remember is this number isn't really 25. It's 2 times 25. So really this number is 50. And if I add 50 on the right side of the equation, I also need to subtract 50 from the right side of the equation. So following what I have now on this second line, I've got plus 7 minus 50. And then if I simplify that one more step further, this is going to say 2 times x minus 5 squared minus 43. And so just like on the last problem, I would encourage you to rewatch this last little 2-minute example so that you, I guess, more fully understand where the different numbers have come from and have good complete notes to go off of in class tomorrow.